Okay, so I keep meaning to do this for a while, to actually have a look in a bit more detail what's happening to these bearings. I've got a big stack of these bearings I've taken out of cars. I've tried to open them before by kind of hitting them on the side, which didn't really work that well. They're quite, where this cage is, it's quite well sort of riveted together. But in the end, I just decided to basically just grind a slot in there, cut that out there and see what's going on. So this is from a Renault Zoe. This was a 2018, done about 110,000 miles. And it's a 5AQ motor, quite common that have bearing issues. These seems to be one more common than the other. So got this apart. So that ball fell out, looks okay. The grease is really dark, but obviously it's overheated. And just having a look, we're outside because the light's a lot better out here. You can see the pitting. I mean, that one looks like the moon. The surface of the metal bearing there has just completely, it kind of disappeared. It's really interesting there that the pitting there actually kind of runs along. Yeah, hopefully that is focusing. I think it is. Let's just move along. The good news is we didn't need a microscope to see what's going on with these. They sound really gravelly. It's not really surprising because the ball bearings are not actually round. I mean, what is going on there? Well, I know there's some smart people out there because a few people have responded when I've talked about bearing issues in the past. This one, let's just get that. This one's got multiple areas of issues there, and you can see the kind of layers. So where's the other? Yeah, that one's really deep there, isn't it? The surface of the balls has literally just broken down, pitted and corroded. So there is a bit of a theory with these, and it's something I've discussed with people before, and someone mentioned it in the comments. That's obviously where one fell out. I was a little bit concerned about cutting the bearings, but obviously I've not done that with a grinder, have I? I mean, this one, yeah, that one's all right, isn't it? That one I've obviously, that could have been with the grinder there, because you can see that there. But so we'll move on. But yeah, let's have a look a bit further around. So yeah, there is a theory. So this doesn't seem totally wear related. That is so deep, that, isn't it? It's like there's a bit gouged out the bearing. Amazing. No wonder and we're back to the one that looks like the moon. No wonder that grease looks so dark, because there's bits of bearing in it. So there is a bit of a theory with these, and it's consistent with what a guy I know from an oscilloscope company, he's done some testing on industrial motors, particularly in wind turbines actually, which is kind of interesting. I hope that is focusing, by the way. I think it is. So the theory is that there is a potential difference, as in a voltage, between the rotor and the case. And what's actually happening is that voltage is discharging through the bearings. So it's basically like micro welds. And they're going through the bearing. Now, obviously this cage isn't connected. It wouldn't go through there. So it's effectively arcing between the outer race and the inner race. So it seems like there's a voltage build-up on that rotor, and it's going onto that inner race, through these bearings, and out that outer race to the case. And that is kind of consistent with what you see on here. On here, if I move the camera. Because although this just looks like rust, there's actually points, it's more apparent when you pull the bearings out and look at the case. Because the case is sort of pitted as well. You can kind of see a bit there, where it's, yeah, this is just, I think, a bit filthy from handling it. But yeah, the case of the bearing just gets, outer race, just gets really pitted. Now, interestingly, on a Nissan Leaf, which is a standard motor design, so as in it has magnets, because a Zoe doesn't have magnets, it has a wound rotor as well as a round stator. A Leaf has a brush on the end of the rotor, and it's purely there to discharge any current build-up on the rotor. Now, a Zoe has brushes on its rotor, but that's for rotor excitation. It's terrible, isn't it? And it doesn't have an extra brush just on the metal of the rotor just to take away any current. And I wonder whether that guy is right, and the person in the comments previously was right, that it is discharged through the rotor. Let's just have a look at some others. Just see if we can see a better example of There's plenty of them around the place. I think these are the ones from the other end. But yeah, you can kind of see here. This is where it seems to have sort of welded itself to the case, and then as I press the bearing out, it's come out with it. You see that? It may just be corrosion. See if I find another example. Yeah, there as well. It's kind of like pitted, and it's almost, yeah, it's welded itself together. Nice blob there. Interesting. People usually spot something. Got a lot of bearings down here as well. Let's grab one of these. Just have a look at these. That was running away. Yeah, I mean, they don't look good, do they? Yeah, so interesting. You can see, yeah, you can see on these. Have a look at that one. So trying to get this to focus is interesting, but there it's like where it's welded onto the case, and then I've pressed it out. And again there, I don't think that's just corrosion. So yeah, let's just have another look at those bearings outside. So I think this is probably right. I think it's probably a design issue with the motor, and because I suspected this is one of the reasons I use a metal shielded bearing. So this is a rubber shield bearing, which is a really interesting design choice anyway, because any rubber shield bearing, nearly all of them, are not actually high speed enough for a motor in the Zoe. You can get light touch rubber seal bearings, so you know, could be a custom made one. But yeah, something's not right, is it? So on the bearings I fit with a metal shield, if this is right, then they can discharge through that shield around the outside, which just gives everything an extra path, and it's a nice continuous path around the outside rather than these bearings just being every, you know, here and there with a little touch point. But yeah, it's not pretty, is it? No wonder it's making a noise. Yeah, pretty interesting. Okay, well, there we are. That answers that question, why they're noisy. I mean, it's really interesting. If anyone's got experience of this, please drop it in the comments. But it's really interesting that that kind of runs along. Is it because the bearing gets a bit stuck? So as it's rotating, you can imagine, obviously that ball is meant to rotate. I guess it's rotating in a line, isn't it? If you imagine that bearing spinning and spinning inside, like this cage spinning inside that outer race, so that's rotating around, so these bearings are turning over all the time. So maybe that's the line that the bearing was sort of running along, if that makes sense. So it would have been, it's really hard to move these, especially with one end. Yeah, another on the other side. Would it, yeah, so if that was a bit straighter, which is kind of hard to do. Yeah, is the bearing running along a bit more like that, almost? Yeah, you see what I mean. If the bearing was kind of like in that orientation, it would be rotating that way. No, it's just moved. Hopefully you get what I mean. But yeah, it's rotating that way as it's running around, and that's what's caused it. It's interesting. So that one's got one there. Has it got the same on the other side in the same place? It's not going to be the easiest to do, but we can roughly... Yeah, it has. So that kind of seems consistent with it being the top and the bottom of the bearing are pitting at the same time. I wonder if this one has. Probably about to disprove me in theory. Yeah, I mean, oh, there's one there. Is that the same one? They're kind of hard to rotate. Oh, there's two together. Pretty nasty. Yeah, it could be. Could be. Yeah, there's one, and then there's two on the other side, isn't there? Quite possible. I mean, you can see the construction of the ball there. It's broken the surface away. Anyway, fun times. Yes, if you've got experience of this failure of bearings, please let me know. But yeah, good to take one apart. Hope that's interesting, and yeah, I'll keep fixing the cars. All right, catch you later.